So remember, when you have an odd multiples of pi by 2, the function changes to co-function. Sign of the trigonometric function depends on which quadrant it lies. So like this, these formulas are used as identifier to find the angles of trigonometric function. So the knowledge of certain small things is very necessary, very important, but very easy theorem I'm saying. Hello everyone, a warm welcome to one and all. This is Shruti welcoming you all to the fourth session of the chapter Trigonometry. In our previous sessions, we have learned the conversion of angle from degree to radians, radian to degree, as well as we have learned the concepts of all trigonometric ratios in terms of radian measure, that is inside the unit circle. Also, we have learned the standard values of all trigonometric functions and solved problems to find the value of a trigonometric function. In today's session, we'll extend the concept of these trigonometric ratios into the trigonometric identities, allied angles, and sum and difference of angles. That is, what are these identity? What do you mean by these allied angles? And what do you mean by sum and difference? So let's start analyzing these concepts of trigonometric functions. The first one here is the trigonometric identities. You have already learned these three trigonometric identities along with few more concepts of cos of negative angle is cos and sine of negative angle is sine. So all the negative angles for cos and secant, it is same, and sine, cosecant, tan and cot. The values of negative angles is negative only, that is minus cosecant x, minus tan x and minus cot x, except for cos and secant. All other angles are negative. And we have also learnt the expression or the identity. We generalize these as an identity. Why? Because we can use in many cases wherever the application of these identities are necessary. Therefore, we call them as an identities. Along with this, we have few more identities to learn where we will apply those concepts in solving the problems in trigonometric functions. First one is the allied angle. What do you mean by allied angle? What happens when you subtract any angles from these quadrants, whether it lies in the first quadrant or second quadrant or third quadrant or fourth quadrant? Based on the angle which fall on any of these four quadrants, we will decide the sign of the function. First one, here you have already seen that sine of negative angle is negative, cos of minus x is cos x, tan of minus x is tan x, cosecant of minus x is cosecant, secant of secant, cot of minus is cot. Except these two, all other are negative. Let's start allied angles of ratios on different quadrants based on the addition or subtraction of the concepts of 0, pi by 2, 2 pi and 3 pi like that. So let's see now. First we have pi by 2 minus x, pi by 2 plus x. Remember, pi by 2 is nothing but 90 degree. So pi by 2 minus x means the angle lies in the first quadrant. In the first quadrant, all angles are positive. Pi by 2 plus x means pi by 2 plus x means the angle lies in the second quadrant. So therefore, only sine and cosecant are positive and the rest of all are negative. So also remember, when you are adding odd multiples of pi by 2, the ratio changes to co-function. What do you mean by co-function? Sine changes to cosine function and secant changes to cosecant function and tan changes to cotangent function. So these are called as co-functions in short. So whenever you are adding or subtracting with pi by 2 or 3 pi by 2 or 5 by 2, 7 pi by 2, odd multiples of pi by 2, the value of the trigonometric ratio changes to its co-function and the value of And the sign of the trigonometric ratio depends on whether they lie in first quadrant, second quadrant, third quadrant or fourth quadrant. Now let's see now what happens for sine pi by 2 plus pi minus 2 minus x. So I said whenever you are subtracting with pi by 2 or adding with pi by 2, the value of all the trigonometric functions changes to its co-function. So therefore, here sine pi by 2 minus x means it lies in the second quadrant. In the second quadrant, all functions are positive. So therefore, sine 90 minus x or sine pi by 2 minus x is cos x. Similarly, cos pi minus 2x is sin x. Vice versa, sine to cos, cos to sine. Changes to its co-function. Similarly, we have secant, then it is cosecant x. Cosecant pi by 2 minus x, it is secant x. Tan pi by 2 minus x, it is cot x. And cot pi by 2 minus x, it is tan x. So, pi by 2 minus x, the function changes to co-function and all the functions in the first quadrant are positive. So, therefore, you have plus, 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 plus in the answer. So, therefore, you have plus in all these ratio. Next, we take for pi by 2 plus x. What happens for pi by 2 plus x? Pi by 2 plus x means it lies in the second quadrant. So, what happens for sine function? Sine pi by 2 plus x, cos pi by 2 plus x, tan pi by 2 plus x, cot pi by 2 plus x, secant pi by 2 plus x, cosecant pi by 2 plus x. What happens now? I said when you have an odd multiples of pi by 2, so the function changes to co-function. So sine must change to cos x, cos sin x, tan to cot x, cot to tan x, secant to cosecant x, and cosecant to secant x. But what about the sine? So pi by 2 plus x means they all lie in the second quadrant. So in the second quadrant, the value changes to co-function, but the sign is minus for cos x, minus cot x, minus tan x, minus secant x, because in the second quadrant, these four trigonometric ratios are negative. So remember this you can learn as an identity, or you can just logically think what happens when you add angle plus pi by 2. So minus pi by 2, where it lies, what is the sign? Next we come across pi minus x, pi plus x. Pi means this. Pi minus x means it lies in the second quadrant. So pi minus x means second quadrant. Pi plus x means it lies in the third quadrant. So what happens for the value here? Now, whenever you have pi or multiples of pi, the ratio remains same. The ratio remains same. That means in previous case, the sine has been converted into cos, cos has been converted into sine, tan to cot, cot to tan. But here, the function will not change, so therefore they remain same. This we can verify through the examples also. We don't have proof for the syllabus, just learn as it is as an identity. Now, let me take sine pi minus x. So, sine pi minus x. In the second quadrant, sine is positive. So, therefore, it is sin x. Next, cos pi minus x is cos x. But in the second quadrant, cos is negative. Tan pi minus x, tan is negative. Cot pi minus x is minus cot x. Cosecant pi minus x is cosecant x, because it is positive in the second quadrant. Secant pi minus x is minus secant x. Similarly, we can write for plus x here. Next, I have written Sin pi plus x, cos pi plus x, tan pi plus x, pi plus x, pi plus x. Pi plus x means it comes in the third quadrant. So in the third quadrant, the value of tan and cot are positive. So except tan and cot, all other are negative values. So you will get the angle in terms of minus cosecant theta, minus secant theta, minus sin theta, like that. So remember, when you have an odd multiples of pi by 2, the function changes to co-function. Sign of the trigonometric function depends on which quadrant it lies. Also, when you have an multiples of pi, the ratio will not change. It remains the same, but again the sign depends on which quadrant it lies. Next we have 3 pi by 2 minus theta, 3 pi by 2 plus theta. You can take theta or x also. So 3 pi by 2 minus theta. 3 pi by 2 means here, this is your 270 degree, minus any angle lies in third quadrant, plus any angle lies in fourth quadrant. So therefore, again I'll take some example. If you have cos 3 pi by 2 minus theta, I said any multiples of pi by 2, the function changes to co-function. So for cos, the function changed to sin theta. But what is the value of sin theta, whether it is positive or negative? In the third quadrant, the value of sin is negative. So therefore it is minus sin theta. Suppose I take cosecant 3 pi by 2 minus theta. Okay, so cosecant 3 pi by 2 minus theta again lies in the third quadrant. So therefore it is minus secant theta. Next we'll take tan. Tan 3 pi by 2 minus theta. So tan and cot are positive here. The function changes to co-function. Okay, but the value is positive here because tan and cot are positive in the third quadrant. Now same concept I can apply for 3 pi by 2. If I take sin 3 pi by 2 plus theta. So sin 3 pi by 2 plus theta means it lies in the fourth quadrant. In the fourth quadrant, cos and secant are positive, all other are negative. So therefore, here I can write it as cos theta because cos is positive in the fourth quadrant. If I take it as secant 3 pi by 2 plus theta. So the function changes to cosecant theta. But what is the value of cosecant? It is negative. So therefore, it is negative cosecant theta. Next we come across 2 pi minus theta, 2 pi plus theta. So this is your 2 pi which is 360 plus theta means again it comes to the first quadrant only. So one complete revolution is over. After this, again plus theta means it lies in the first quadrant only. So this is plus theta and this is minus theta. In your first quadrant, all functions are positive. In your fourth quadrant, only cos and secant are positive. Let me take few examples. So as we have found the values in our previous session, for example, let me take sin 420 degree. Sin 420 can be taken as sin 360 plus 60 degree. See, 360 means your 2 pi plus theta. So your sin 2 pi plus theta is sin theta only, which is nothing but sin 60 degree. What is the value of sin 60 degree? Root 3 by 2. Sin 420 is also root 3 by 2. So remember, I have told you whenever one complete revolution is over, the value of the trigonometric function repeats. So therefore, we have taken the identity. Remember, sin 2n plus pi plus x is same as sin x. It is same as sin x. Whatever the values you will get for sin x for all angles, the same angles will repeat for after 360 also. So therefore, the value of sin 420 is same as sin 60, which is nothing but root 3 by 2. So the same concept I have applied here. You can see 360 plus theta. Sin 2 pi plus theta means it lies in the first quadrant. So therefore, the value is positive, which is sin 60. So we have taken on problem that is cosecant minus 1410 degree. So this can be written as cosecant, we know this minus of x is minus cosecant 1410 degree. This is actually minus cosecant of 1440 degree minus 30 degree. So that is minus, so 1410 is nothing but multiple of that pi, that is 2 pi into 4 times you will get, which is 360 into 4. So 360 minus theta means it comes in the fourth quadrant. In the fourth quadrant, the value is negative. So therefore, the cos of 30 you should take it as minus cosecant 30, because in the fourth quadrant, the value of cosecant 30 is negative. So therefore, it is minus of minus 2, which becomes plus 2. The concept of, there we have used the concept of the quadrants, and so the same concept of allied angles was used in our previous session to solve the same problem. So what you have to remember is, when you are dealing with this kind of function, that is pi minus 2 by theta, pi plus 2 by theta, 3 pi by 2 minus theta, 3 pi by 2 plus theta, the function changes to co-function. That is, sine changes to cos, tan changes to cot, and secant changes to cosecant. When pi by 2 minus theta, pi plus 2 theta, 3 pi by 2 minus theta, 3 pi by 2 plus theta. And the sign depends on where it lies. For example, if you take this pi by 2 minus theta, then it is plus, because in the first quadrant, all the functions are positive. So therefore, sine pi by 2 minus theta can be directly write as cos theta. And if you take the same function as pi by 2 plus theta, there sine pi by 2 plus theta will become minus cos theta. Why? Because cos theta is negative in the second quadrant. So therefore, for multiples of pi by 2, the function changes to co-function. Sign depends on which quadrant the function will lie. But the function remains same. Whenever you have multiples of pi with plus or minus theta, sign do not change to cos. Sign remains as sine, tan remains as tan, cot remains as cot. But again, the sign depends on where the trigonometric function will lie. So this is a short note on allied angles. Keep it in your mind, because it is very useful in solving the problems. In according to this, in your syllabus, we have the functions of trigonometry in terms of sum and difference, which you will learn as an identity. But one important derivation for this is, prove geometrically cos of x plus y is equal to cos x cos y minus sin x sin y. So this is nothing but sum or difference of any two angles. Here I am going to derive the sum of cos function. For example, cos 75. We doesn't know the value for cos 75. But I can write cos 75 as a sum of two standard angles which you have learned. That is cos 30 degree plus 45 degree. How to find the values? Use this formula. Express this as cos 30 cos 45 minus sin 30 sin 45. So you will get cos 30 as root 3 by 2. This is 1 by root 2. This is 1 by 2. 1 by root 2. So this is root 3 minus 1 divided by 2 root 2. So this is the value of your cos 75 in terms of real numbers. So like this, these formulas are used as identifier to find the angles of trigonometric function when it is not a standard angles like 0, 30, 60, because we have already learned what are those values. Exceptional cases like this we can find using the sum or difference of trigonometric functions. Now, this is the derivation important for 5 marks question. Here we have a theorem, prove geometrically cos x plus y is equal to cos x cos y minus sin x sin y. Again, we are using the concept of unit circle to prove the theorem. Why? Because all trigonometric ratios are studied in terms of radians here. Therefore, we are using the concept of unit circle again. And remember, this theorem is compulsory question in your part D. Compulsory question. So which carries 6 marks, but this theorem is for 5 marks. Along with this, you will be given one additional question which we will use the same identity to solve those questions. So very important derivation in your syllabus as well as for your examination purpose. Part D, compulsory question. Every year you have this question in your 6 marks. Now, very simple theorem. Understand it very carefully. Watch each step because many steps contain reasons in your earlier classes. So the knowledge of certain small things is very necessary, very important, but very easy theorem I'm saying. So prove geometrically cos of x plus y. Also, the diagram is compulsory. Without diagram, you cannot derive this. So in your examination, first write the diagram part, then go on writing the proof part. Now, here is what I'm telling, that is your statement. That is, consider a unit circle with radius, that is, consider unit circle here, okay. Then, we are taking an angle, that is x. Consider the unit circle. Let me take an angle x here. And what do you mean by angle x? Whose radian is also equal to x. So, x radian means it should have an arc length of x distance. So, therefore, I am taking an angle x here. Also, let me take one more angle, that is angle y here. This is your angle y. And the distance from here to here is nothing but your y. Because for y radian, the arc length is y. Similarly, I am taking one more angle here. That is your minus y. So, the distance is y because distance cannot be negative. So, therefore, the arc length is y for this also. But here we are measuring from anti-clockwise. So, therefore, positive. And here it is negative angle because we have measured in clockwise. No difference in positive. No difference in y. If this is 30, it is minus 30. Minus means you have measured in clockwise direction. So, now I have taken these points as P1, P2, P3, P4. So, let me explain with one more circle here. So, let me take a unit circle here and I have taken, this is your x coordinate and this is your y coordinate. This is your origin. I have taken an angle x here. I have taken an angle y here. And from here also, from here with the same measurement, I have taken an angle in a negative direction, that is your minus y. What I am doing here, so I have taken this as point 1, I have taken this as point P2, this is point P3, point P4. In the next step, I am joining P1 to P3 and P4 to P2. This is what I got inside the circle. This is the diagram. So, joining P1 to P3, P2 to P4. So, whatever you are constructing in the circle, you have to explain it in words. I'll explain once again. Consider the unit circle with O as an origin. Let X be the angle. That is P1O, P4 be the angle. Next P1O, P2 is equal to Y be one more angle. P3O, P4 be one more angle. Next, join P1, P3, P2, P4. Now what? You are getting two triangles here. What are those triangles? One triangle is this. That is the triangle you got. That is P1, P3. This is the one triangle. And one more triangle you have P2O, P4. That is like this you have. This is your P4. They are these two triangles. They are congruent, I'll say. Why? Because when we say two triangles are congruent, when two angles one side are equal, when two sides one angle are equal, when all the three sides are equal. The same concept is applying here. See the sides P1, P4, P2, P3. What is it? The radius of the unit circle. Their distance are same. So therefore, two sides in the triangle are equal. And one angle, this. Okay, this angle and this angle are equal. So using ASA postulate, remember in your early classes, remember the concept of postulates in your early classes to prove the congruence of a triangle. So the same concept I'm using here. From this, I can say the triangle P1, O, P3. That is triangle P1O P3 and the triangle P2O P4. That is P2O P4 are congruent triangles. So if they are congruent triangles, what I can say? The side P1 P3 and P2 P4 are equal. If two sides and one angle are equal, the rest of the sides and the remaining angles are also equal. So the same concept, if these two are equal, then what I can say? The side P1 P2 is equal to P2 P4. So I hope you understand about the diagram. Consider the unit circle, taken an angle x, angle y, angle minus y. Join P1 P3, P2 P4. You got two triangles. One is P1O P2. One is P1O P3. Another one is P2O P4. They are congruent using ASC postulate. So therefore, what I can conclude is P1 P3 is equal to P2 P4. This is using the congruency of these two triangles. Now, you remember the distance formula in your earlier classes. That is distance formula. Suppose you have any AB. A line AB. This is your point A, point B. Then it is given as x2 minus x1 whole square plus y2 minus y1 whole square. The same concept we are using to find the distance of P1, P3, P2, P4. Then, one more important thing you have observed here, all the coordinates here we have expressed in terms of cos and sine. Why? We have learned in our previous session, any point on the circle can be expressed in terms of cos x and sin x. Since the angle is x here, it is taken as cos x and sin x. The angle is y here. So, but why it is cos x plus y, sin x plus y here? We have considered this complete angle here. This angle is the sum of x and y. So therefore, the coordinate here is taken as cos x plus y, sin x plus y. And what about this coordinate? This is your angle minus y. So therefore, the coordinate at this point is taken as cos of minus y, sin of minus y. This point is clear. It lies on the x-axis. X coordinate is 1 because it is unit circle. Y coordinate is 0. So your fourth point is P4 1, 0. Now let me apply the distance formula from P1 to P3 and P2 to P4. Now here if you want to remove a square root, what you will do? You will take it as AB square. So the same concept I'll apply here. So if you square on both sides here, P1 P3 square is nothing but P2 P4 square. First let me take it differently. Let me see what is my P1 P3 square. P1 is cos x sin x. P3 is cos x plus y sin x plus y. Apply the concept as x2 minus x1, y2 minus y1. What I can write here is cos of x plus y minus cos x whole square plus sin of x plus y minus sin x whole square. Now this is in the form of a minus b whole square, a minus b whole square. Let me express this. This becomes cos square x plus y plus cos square x minus 2 cos of x plus y into cos x plus again a square plus b square minus 2ab. So sin square x plus y plus sin square x minus 2 sin x plus y sin x. Here you can see, we know the identity, that is sin square plus cos square is equal to 1. So therefore, what I'll do here, I'll take sin square plus cos square as 1. You can see here, these two. The value is equal to 1. Cos square x plus y, sin square x plus y is 1. Similarly, cos square x, sin square x is 1. So the rest of the thing I'll write as it is. So therefore here, P1 P3 whole square is equal to 1 plus 1. Now after procedure, we have got that P1 P3 is equal to P2 P4. So P1 P3 is equal to P2 P4. How to find the distance of P1 to P2? Using distance formula. So remember, in your earlier classes, you have studied the distance formula. So that is square root of x2 minus x1 whole square plus y2 minus y1 whole square. The same concept I am applying here, but here you have AB. So square root. So if you don't want square root, you can write this as AB square is equal to x2 minus x1 whole square plus y2 minus y1 whole square. Now here the same concept I'll do. P1 P3 whole square is equal to P2 P4 whole square. So no need to put square root, directly apply x2 minus x1 whole square plus y2 minus y1 whole square. Now we are taking this line, that is P1 P3. You can take any one as x1, any one as x2. So I'll first find P1 P3 whole square. Apply x2 minus x1 whole square. So this becomes cos of minus y minus cos x whole square. Similarly here, sine of minus y minus sin x whole square. So now this is in the form of a minus b whole square formula. What is a minus b whole square formula? A square plus b square minus 2ab. So this is cos square of minus y plus cos square of x minus 2 cos of minus y cos x. Similarly, here we have plus sine a minus sine. So this is sine square of minus y plus sine square x minus 2 sine of minus y sine x. Now we know the identity. Sine square x plus cos square x is equal to 1. If the angles are same, the square of sine and cos, the sum of squares of sine and cos is 1. So the same concept I'll apply here. This you can see, this is in the form of sine square x plus cos square x. So therefore I can just replace with them 1. Next, the same concept here, you can see cos square x plus sine square x you will get, which is nothing but 1. Now coming here, you have here cos of minus y. What is cos of negative angle? It is positive. That is cos of minus x is cos x and sine of minus x is sine x. So therefore here I'll write 2 cos y cos x, and here minus, since 2 sine of negative is minus, so it becomes plus sine y sine x. So what happens here? This is 1 plus 1, which is 2. 2 minus. If you take 2 as a common factor, you will get this as cos x, cos y minus sin x, sin y. So this is your P1, P3 whole square. So let me take this as equation 1. Next, I have to calculate this distance P2, P4. Next, I have to calculate this distance P2, P4. So P2, P4 whole square. So you can take any one. So this becomes 1 minus cos x plus y whole square plus 0 minus sin x plus y whole square. So this is now again a minus b whole square formula. 1 square plus cos square x plus y minus 2 cos of x plus y, and this is completely no 0, this is sin square x plus y. Now observe this, cos square x plus y, sin square x plus y. It is in the form of cos square x plus sin square x. So I can take it as 1 plus 1 minus 2 cos of x plus y. So you will get 2 here. So P2, P4 whole square, 2 is here. If you take 2 as a common factor, you will get it as 1 minus cos of x plus y. Now take this as equation 2. So we have got P1, P3 whole square is equal to P2, P4 whole square. So equate this. P1, P3 whole square is equal to P2, P4 whole square. What is P1, P3 you got? 2 minus 2 cos x cos y minus sin x sin y. So 1 plus 1 is 2 minus 2 cos x plus y. Now this one we have, take it as equation 2. We have got P1 P3 whole square is equal to P2 P4 whole square. So what is P1 P3? Equation 1. Now equating 1 and 2. We can equate 1 and 2. What we will get? P1 P3 whole square is equal to P2 P4 whole square. So this we got 2 minus 2 cos x cos y minus sin x sin y. Here we got 2 minus 2 cos of x plus y whole square. So in the both the side you can cancel 2. Then you will get minus 2 cos x cos y minus sin x sin y. This is equal to minus 2 cos of x plus y. So again minus 2 get cancels. What is left? We have cos x cos y minus sin x sin y. This is equal to cos of x plus y. Hence, we have derived a identity, that is cos x plus y is equal to cos x cos y minus sin y. A very important problem for your examination. So again, once again I'll explain you. So consider a unit circle with origin O. Let x be the angle, or you can take let P1O P4 is equal to x, P1O P2 is equal to y, P3O P4 is equal to minus y. Then the coordinates of P1, P2, P3, P4 are cos x plus y, sin x plus y, cos of minus y, sin of minus y, 1, 0. Then join P1, P3 and P2, P4. So you will get two triangles. Therefore, the triangles P1O, P3 is congruent to triangle P2O, P4. Write the reason. What is the reason? We have two sides, they are equal. Therefore, the third side can be equal. Or you can write SCIS postulate, using SCIS postulate. Then what we can conclude? P1, P3 is equal to P2, P4. So I have to find the distance of P1, P2, P1. I have to find the distance of P1, P3, P2, P4. So using the distance formula, I can square them and find the distance formula. So how we will get? So P1, P3 means P1, P3. Subtract in the form of cos minus y minus cos x. That. So we have got here, so cos of minus y minus cos x whole square, sin of minus y sin x whole square. Using the formula of a minus b whole square, expand this in the form of a square, b square minus 2ab, again a square minus b square minus 2ab. We know that sin square x plus cos square x is equal to 1. So this is same as sin square x plus cos square x. The angle value is same, so therefore the sum is 1. Similarly, it is equal to 1. And write the remaining term. So 1 plus 1 is 2, and you can take 2 common factor here. This you will get in this form, cos x cos y minus sin x sin y. Take it as equation 1. Next, take it for P2 P4 whole square. Take it for P2 P4 whole square. Apply the concept of x2 minus x1 whole square, y2 minus y1 whole square there also. So after reducing this, you will get it as 1 square cos square x plus y. 0 minus sin x plus y is sin x plus y. When you square it, it becomes a sin square. And cos square plus sin square is 1. So here we have replaced it 1. 1 plus 1 is 2. And the remaining right as it is. Take it as equation 2. Since we have taken these two are equal, so I can write it as, so the equation 1 here, equation 2 here, cancel 2 on both sides. We are left with this. Again cancel minus 2 on both sides, so we can conclude. So therefore we can conclude that cos of x plus y is equal to cos x cos y plus sin x sin y. This is the basic formula or basic identity you are going to use for all those cases whenever it is applicable. Here we have one of the application of the previous theorem. Cos x minus y is equal to cos x cos y plus sin x sin y. What we know from the theorem, that is cos of x plus y is equal to cos x cos y minus sin x sin y. Now what I need is, here in the place of y I have minus y. So replace y by minus y. What happens here? Cos x minus y. Here it is cos x cos of minus y, sin x sin of minus y. What is cos of minus y? It is cos y only. What is sin of minus y? It is minus sin y. So using this concept here, I can write cos x cos y. When you put minus sin y, this becomes plus, which is sin x sin y. Now this is your cos of x minus y. No need to prove it again geometrically. So this type of question is added with the theorem. So therefore it carries 6 marks question. 5 marks for the proof of cos of x plus y and 1 additional type with the application of the previous theorem. Next we have sin x plus y is equal to sin x cos y plus cos x sin y. Here sin we have given, but the theorem was about cos. But we know the allied angle property. We know that sin of pi by 2 minus theta is cos theta. Similarly, cos of pi by 2 minus theta is your sin theta. So the same concept I am using here, you need your sin, but you can express in terms of cos. So let me write sin in this form. So what happens here? This is cos of pi by 2 minus x plus y. Let me write this as cos pi by 2 multiply minus, this is cos pi by 2 minus x minus y. Now this is your x term, this is your y term. Now this is in the form of cos x minus cos y. What is cos x minus cos y? Cos x cos y plus sin x sin y. I'll apply here. So this is cos x into cos y plus sin x into sin y. Now what is cos pi by 2 minus x? Cos pi by 2 minus x is your sin x. So this is sin x cos y plus, what is sin pi by 2 minus x? It is your cos x. The ratio changes, which is sin y. So see here, this is what you got, that is sum of sin x plus y. So sin x plus y can be expressed as cos pi by 2 minus x plus y using the concept of allied angle property. Then again using the cos x minus y formula, we can just derive. So in the same case, any trigonometric functions they give in sum or difference of the angle, we can just use the formula of cos x plus y and the concept of allied angles to find or to prove the identity. So I'll show you a few more cases. We know that cos of pi by 2 minus theta is equal to sin theta. Let me prove this using the concept of sum and difference of angles, okay? So this is in the form of cos x minus y, isn't it? So cos x minus y means cos x cos y plus sin x sin y. Let me see whether I'll get theta, that is sin theta. So now if I write this here, this is now cos pi by 2 cos theta plus sin pi by 2 sin theta. What is cos pi by 2? 0. 0 into cos theta, 0. What is sin pi by 2? 1. 1 into sin theta, sin theta. What is your value? Sin theta. This is the proof for your allied angle property. So using the sum and difference concept of trigonometric function, we can prove all other allied angles property also. Let me take one more example. We know that here is one more property, that is tan of x plus y is equal to tan x plus tan y divided by 1 minus tan x tan y. So all these identities, that is tan x plus y, cot x plus y, cot x minus y or tan x minus y, just learn for your purpose, that is learn it as an identity, no proof in your syllabus. So therefore tan x plus y is nothing but tan x plus tan y, 1 minus tan x tan y. Similarly, we have tan x minus y as tan x minus tan y divided by 1 plus tan x tan y. Let me show you one more application of these cos x plus y formula. We know that sin 2 pi plus x is sin x. That we have learnt in allied angles. Sin 2 pi plus x means it comes in the first quadrant. The ratio will not change. Therefore, sin x we have learnt. But let me see the application of cos x plus y here. We know the formula for sin x plus y. What is the formula for sin x plus y? Sin x plus y is sin x cos y plus cos x sin y. We have learnt and derived it. So now, this is now sin 2 pi plus x. Apply here, it is sin 2 pi cos x plus cos 2 pi sin x. Sin any pi is 0. So 0 into anything is 0. So therefore this is 0. Cos 2 pi, that is cos 360 degrees 1. 1 into sin x is sin x. So therefore it is sin x. See, this is what we get. The proof of allied angle property. So all the allied angles property can be proved using the sum and difference of trigonometric ratios. So in today's session, we have learned all the allied angle properties whenever you are going to add any angle with respect to pi by 2, pi, 3 pi by 2 or 2 pi. Also remember the signs of trigonometric quantities. Also remember the signs of trigonometric quantity based on all 6 trigonometric functions in which quadrant they lie. So accordingly, the positive and negative values changes. And remember, when it comes to the allied angle property, the function changes to co-function when it comes to the odd multiples of pi by 2, and the function will remain same when it is added or subtracted to pi, 2 pi or any multiples of pi. Along with that, we have learnt a very important concept of proving the cos x plus y formula using geometrical proof, which is very important question and compulsory question for 5 marks in your examination. Along with that, you will get 1 marks question to prove using the concept of cos x plus y. So in the next class, we will see few more application of the cos x plus y formula, where we will learn it as an multiple angles, submultiple angles and transformation formula. Until then, keep watching, keep learning and keep exploring. Thank you.